Gentlemen, I'm gonna switch to Turkish. It's better to talk Turkish. You'll get translated. Herkese merhaba.
Good afternoon. Welcome to the session. We're about to come to the end of this a series of rounds in the last 2.5 days. I would like to welcome all the participants, panelists, speakers, all the colleagues for attending. Now, today, in this session, we also want to give a detailed discussion of the wind industry from a different perspective, from the perspective of service and maintenance. The agenda we have in Turkey is mostly striving around how to utilize or even mobilize this potential. Mostly we're discussing as to how we can convert sites into investment and how we can complete the investments. Quite naturally, we are discussing around this. But on the other hand, in Turkey, by the end of 2014, there was the installed capacity up to 3,700. So we shouldn't underestimate the fact that there are like 1,500 turbines running in Turkey. Most of them do have availability guarantees. They do have 5 to 10 year service and maintenance agreements concluded. Electricity generators are getting this availability guarantees, which I have to say that this is a remarkable sector, a remarkable market. Just imagine this year if we manage to complete another 1 gigawatt and next year another gigawatt of capacity installed, counting every year with 1 gigawatt in average, we can speak about almost 250 up to 300 extra turbines to be installed in Turkey, which makes the industry quite a remarkable marketplace and a remarkable activity field. So we want to discuss around these matters in this final session where we will have 4 distinguished speakers. Mr. Levent Ishak is the service manager of Vestas Turkey and Pakistan. We have Mr. Michael Neumann as the head of sales of Central Eastern Europe Wind Power Services of Siemens. Dear friend Dr. Slim Soa is here from the British TWI company as the CMS section manager. I, by the way, will be introducing them one by one before their presentations. And also we have Mr. Kenan Hayfavi as the Deputy General Manager of Gamma Energy. Mr. Kenan is also a member of the Board of Directors of the Turkish Energy Association. We are serving to our country together in the board. Now, the first speaker of the session will be Mr. Ishak. But before letting him speak, I would like to provide you a brief CV. Mr. Ishak was born in Trabzon in 1973 and a graduate of the Mechanical Engineering Department of Dokuz Eylül University. In 1998, the Ares Çeşme, being the first BOT wind power plant in Turkey, was his very first place of employment. Until 2003, he worked in the measurement station as installation, and also he worked as a part of the feasibility studies of potential wind power plants in TÜBİTAK and Dokuz Eylül University. He was a member of the mechanic design and assembly works of a 5 kilowatt of a turbine, which is a joint project also for the water pumps installation. Until 2008, he worked for Tetra Pak as the mechanical maintenance chief and as the PM pillar leader. After 2008, he became the operational manager of Vestas Turkey. As of 2011, he's the service manager of Vestas Turkey, married with 2 children. Okay, the floor is yours, sir. Each speaker will have a time limit of 10 to 15 minutes, if possible. This can only make it possible for the Q&A session. Mr. Chair, thank you very much for your kind words. My distinguished colleagues in the panel, dear participants, actually the final hours of fairs, congresses are quite challenging times, I know. In addition to that, have lost my voice because I've been sick, and the doctor said I am not allowed to speak for more than 5 minutes. But taking this opportunity, I would like to introduce myself and my company as much as possible. Hopefully, you'll find something useful for your daily operations. Maybe in the future, we can have some other ways of working together. This is a slide that I like very much. Normally, a car in 4,500 hours will be a part of scrap, according to a study that is done in Europe. If a wind turbine is similar with a car, then every 6 months we need to be replacing it. But when designing wind turbines, we are designing them for a lifespan of 20-25 years. Actually, they're working on the huge dynamic loads in that time span. We're all familiar with investment problems in Turkey. We have challenges at the level of investment. We know how challenging job it is to commission a turbine. Probably in the previous sessions, you've all heard different people speaking about it. And from the very moment of commissioning the turbines, after the investment stage is over, there is the real life that's starting. Feasibility works and everything will now have implications over what you have already done. You will evidently understand how healthy your analysis have been, whether the proper team has been set up, whether the spare parts are available, and even whether your forecasts will find a reality or not. Of course, no investor would like to come across with surprises here. Of course, the biggest concerns of investors is the cost of energy, because as the cost increases, return on investment would sometimes be so high as would not be feasible. This is an engineering graph. Actually, this is the way it works. This is the bell curve, as we know. As the first turbines are commissioned, there are startup challenges, as these are the birth problems, and there will be a plateau level, and after a while there will be an increased cost because of maintenance needs. The first times will be generally covered by the warranties of the manufacturers, and the costs will be covered. This then will be followed by the period of contracts that are concluded with the manufacturer. This is like a time for the maintenance cost, where most of the costs will be borne by the manufacturer. In this case, as the time goes on, where the losses are increasing or the breakdowns are increasing, according to a value calculation, there are 3 different scenarios that can be expected. So taking an average of these scenarios, the red traced area will be the customer's risk. The investors, of course, are willing to minimize this risky part. So what do? We, as Vestas, do provide solutions or maintenance packages to minimize such risks. So we are providing assistance to the investors for minimizing the risk. So how do we do that? There is the active output management philosophy that will be embedded into the packages. By using the right people and the right intelligence, with the right operations and maintenance plan, and the right infrastructure and a strong partnership, our aim would be to run these activities as smoothly as possible, where the reliability of the turbines would be provided with minimum problems, potential problems. One of the most important factors is well-trained human power. There have been many words said about this, but there are, of course, many trainings that can be provided to the staff. And most importantly, about labor safety, about labor health, they should have some experience on site and some philosophy. I think this is the foremost priority that our company is following on site. This is to be followed by the data collection on field, plus continuous monitoring of the data that will just have an online access to information and data on machinery and equipment. Therefore, we need to improve the preventive maintenance services and predictive condition-based maintenance services, which can only be possible through the analysis of proper data. A correct maintenance plan would not necessarily mean a very high or very low maintenance plan in terms of cost. But of course, consider an asset with an average lifetime of 20 years. But the conditions for maintenance should be in optimum conditions. Therefore, we should have a good search as to how this maintenance plan should be. And next comes, of course, the best implementation of this plan. Number one requirement of maintenance is resource management. Besides human resources, we mean the necessary spare parts and availability. And of course, we need to make them available as quickly as possible to the site, which is extremely important for the smooth functioning of the operations. At the same time, we need to provide the interventions on site as quickly as possible. This would also minimize the cost to the breakdown times. And there, of course, is a way of working with the right partnership. The ultimate aim of all of us is to have the ultimate performance of this asset. This takes the right partnership, understanding each other, speaking the same language, and having a proper understanding of what we are expecting from each other. We need to elaborate on that with our partners. But one question, is this enough? So far, I have been covering as to what needs to be done for maintenance. I mean, within the routine maintenance, there are just routine maintenance works, breakdown times. But when a wind turbine is designed, there are some measurements that are made based on the values taken from the wind measurement stations. But there is a turbine that is surviving there, and there will be more than one turbine surviving in different locations. Here comes in an important issue that needs to be highlighted. After-sales services is somehow different than the operations, because here what we're aiming is something else. Vestas, under its umbrella, has an already existing installed base more than 60 gigawatts. So the site is quite large. And this installed capacity corresponds to almost 26,000 turbines that are being monitored online, that are being called online for data collection. The aim here is, together with the data that we receive, we always search as to how we can optimize the field and how we can increase the output of the site. And of course, we try and attempt to increase the initiatives to be taken to improve such. The first picture is, as you can see, nothing. There is just a mast, just making some measurements. But the second one is the turbine, a series of turbines existing. When setting up the site, we get information from the met mast, but when at the time of functioning, we get data from the sensors of the turbines, all of which serve for how we can optimize the site. This actually is not a matter of forecast, but it is entirely a scientific statistical survey. More than 26,000 turbines are monitored online, and more than 52 turbines installed in 73 countries are being followed, and close to 4,000 met masts are providing all the data, which altogether will be collected in a center to provide us some information. In 2011, Vestas built up and commissioned a computer system, a computer facility that back in those days were the largest third installed computer facility ever in the industry. Now, the computer facility, starting of 2011, even as of 2010, worked to receive all the wind data existing ever, to evaluate such data, collecting mesoscale maps from different sources, and creating some maps on the sites for this data, and of course having implications over the operations for the weather conditions that will have real implications in real life. Now, after that date, we were able to have an understanding as to how far we can go in pushing that particular turbine.
Buradaki en büyük altını çizmemiz gereken
One thing I need that deserves to be highlighted at this point is, in a mesoscale map, we obtain values and how much it's matching with the real site figures, and what is the correlation factor. We use Vestas Site Check as a software that also complies with the type certificate, and it provides us reporting, which is not a forecast, by the way. This rather is beyond a goodwill work, but is based on scientific background, on online data collection system. Therefore, it's really something serious that it can do, which takes really expertise to do that. What do we do as a result? There are three main bullet points that we are concentrating: power upgrade, extended cutout, and aerodynamic upgrades. These are the main three aspects where we can maximize the output from a particular turbine. Thanks to that, the data that is obtained from the site can be increased by up to 5%. Power upgrade, you might have probably heard, is the increase of production by fully utilizing the available load margins. Upgrade portion can also increase the rated power up to a higher level, which all the data, mesoscale, and the detailed data from the field would be used, where we can just jump from 2 megawatts to 9 or even further megawatts. But the first question that will come to your mind is about licensing. But of course, this is going to cover the entire site, not particular turbines in a site. Also, in an average wind range, you can get a quite high efficiency with the system. Extended cutout. As you know, there is a working range of the turbines in meter per second in the turbines. This sometimes can be a storm threshold in some of the turbines, which the feasibility will be based on. But we are forcing the 25 m per second value according to the site conditions. So when we take a look at the site and the data, we check whether there is really room in the turbine to increase this up to further, like from 25 to 30. Whether we can just increase our capacity. These are actually about getting correct, accurate data from site. And this has somehow to do with a matching of the climate and mesoscale data. Now, so far, I have been covering the site operations about upgrading the turbines, but there is one thing that I think we need to spend some minutes on. This is something, probably something that needs to be said the first, but don't know why the last messages are kept in mind better. Whatever we do, we never should compromise on these three. It's applicable not only to our industry, but you would appreciate that it's a must for all the industries, because human health, labor safety, and environment are the three main aspects that we shouldn't be compromising over when doing business in this industry. Thank you very much for your attention. And if you have questions, I would be more than happy to get them, I think, after the presentations. Thank you.
Çok teşekkür ediyoruz Levent Bey'e. Çok hızlıca.
Thank you, Levent. Our speaker has provided us some information about the operation period. Now, the operation is the time, of course, we know is quite remarkable when everything is becoming a reality that is just moving from what's written on paper. Vestas, as a turbine operator, is trying to minimize the investors' risks, so they are following the active output program. Of course, there is something we have to keep in mind, the well-trained human capital, which is number one priority. But by itself, it's not enough. Therefore, we should be taking actions based on data we are collecting from site. The speaker provided us some information about the more than 26,000 turbines, where they are simultaneously collecting data and turning into actions. Like, for instance, they have three studies that they're following, as after the turbine is commissioned, to improve the performance of the turbine, power upgrade, extend cutout, and the third one, aerodynamic upgrades. And of course, when doing all of this, Mr. Ishak focused on human health, environment, and labor safety as three important pillars. Thank you very much for this valuable information, Mr. Ishak. Now, the next speaker will be Mr. Michael Neumann. Let me introduce Mr. Neumann with his brief CV. In 1967, he was born in Germany, and then in 1991, graduated from mechanical engineering of Berlin University. Since 1991, he has held different positions in Siemens, particularly for fossil and renewable energy fields. And since 2008, he has been holding his current position as the head of sales of Central Eastern Europe. Mr. Neumann, I would like to give you the floor now, sir.
Yeah, welcome, and thank you for being here at that late hour. So I have the pleasure to talk a bit about service from a slightly different angle than my colleague did. I will focus a bit on the service from the requirement side. What is required in service? And I'm doing it because sometimes, especially in the beginning of a project, service is considered as the stepchild of everything. So nobody's really looking into it. But if you consider it, and we have seen this nice car there in the previous presentation, we as service will stay with you over 15 or 20 years. So we will make sure that your machines are reliable, that they will produce, and that the machines bring what you have expected. So it's a very important asset, and therefore service should not be underestimated. So there are a couple of questions which have to be asked in the beginning when you decide for a service provider. What is the company of your choice able to deliver? Is a question. Does it fit to my needs now and in future? So are they reliable and deliver when needed? Will the service company sustain over the term? And at the end, can I, as the customer, afford the delivery? Not only the money, but also the value side of it. All these questions are very important to be answered in the beginning. And I'm trying in the following to explain it a bit on a few examples what our company is providing. First, Siemens is a global organization. We are working across the world, all places, but we have the philosophy of acting local, because we believe that the local setup is important to be successful in specific markets, having the same language, same culture. So this is one of the major goals which we are following through. As we can see here, and since we are in Turkey this time, Turkey came into the Siemens landscape in 1907. And as you know, Siemens was founded in 1856, so I mean it's a short while, in a way, after Siemens was founded. And people in the Siemens are saying that Siemens has more offices in all places in the world, more than the German embassies are spread over the world. So we are everywhere since more than 150 years in some cases. Coming to Turkey. Turkey is also a nice place for the Siemens business. As you can see here, in 1933 there was the first steam turbine installed in Turkey, and as far as I know, this machine is still working in a sugar factory up to today. In 1968 then Siemens started the energy business, and since then we are in any kinds of energy business in Turkey present and active. So coming a little bit more to Turkey, because it's outstanding here, this Turkish organization has 3,000 employees, 3 production sites, R&D center, and 8 offices across the country. So it means we are almost in every place in this country. The interesting fact and outcome of this is that Siemens is providing or supplying 15% of the electric supply in this country. And this is the energy side. We are doing healthcare, we're doing everything else. But the other interesting part is that with our manufacturing sites here in Turkey, we are also delivering into 60 countries outside of Turkey. All follows the idea we are globally thinking and acting locally. But this, so far, has nothing to do with the service or with the wind power. Wind power is a relatively young business, also in the Siemens Turkey world, or almost in Turkey. So I show here the few sites which we have in operation, which is up to 235 megawatts at the moment, but we are lucky that we have now contracted 574 megawatts, which is referring to 206 wind turbines. So if you consider the growth in the market here, so we are not the biggest player, but we are catching up, and definitely the goals are set. I cannot tell you exactly where, but they are significant. So we will take part in this development of this country. But the key values, what is important again for a company like us? So we put safety in the first place. So because the people we are working with, working in dangerous conditions, and we want to make sure that these people are safe and healthy throughout their life. So therefore we are not compromising on safety at all, which is, in some discussions I had, a little issue, because it was stated that you are so strict on safety, can we work with you, because this is the German approach and so forth. But so far we have experienced and have seen that even though if we are looking on the safety of our people, we have, the flexibility which we need in the market. Second is quality. Quality is a must. If you don't have the quality, you don't have a product, you don't have success. So we are looking for error-free processes as good as we can, and improving where we have to improve. Responsiveness is another value of us. So we have to be responsive to all needs of our customers. And this is not only us, everybody should have this approach, looking after the customers, listen to them, and do respectively actions. Satisfaction is hopefully a result out of this responsiveness. So we need satisfied customers so that they like the service and understand what we are doing and appreciating what we are doing. And this will lead then at the end in business result, not only ours, but also the business result of our customers, because they at least earning the money with their machines, and we taking a certain portion of it. And if they don't be successful, what does it mean? Nobody will be successful. On the other side, if we have talked about the values, we have to think about what a service provider needs to provide in this business world. So the so-called areas of excellence. What everybody can do is scheduled maintenance. Everybody means smaller companies can do it. I mean, you don't have to be Siemens to do a scheduled maintenance. But there's a lot more. We have the monitoring, all the SCADA, RDS, remote diagnostics, monitoring, technical support, which is coming under this keyword monitoring. Then you have warranty management. So if something happens, you have to have a supplier or a company who's able to analyze these faults and find the right actions, have the spare parts, and execute accordingly. That is for some companies of smaller size more difficult than for bigger ones. And I mean, I consider us as a big one, so we have this in our portfolio, and this is important for us. Training is something, either our training for our people, but as well as customer trainings which have to be provided, because only experienced and skilled people should work on the machines and should be maintaining those machines. But there are also cases where warranty obligations are let's say, becoming important. So availability warranties, which we have in almost all sites, or part defect warranties, which is a little bit the story that in case something happens, we repair it and replace it. We have certain programs in our portfolio which are entertaining this. Operation management is clear. This is the whole operations, and then lifecycle management as a last. And here I just focus on a little piece, which is the modification and upgrades, which is another part of, let's say, simple little thing in the whole value chain. So typically, and this is the main experience I have, people have the idea, we have a machine, we install it, we maintain it once a year, and that's it, and it runs 20 years. This is not the case. If you have a valuable service provider, he is able to develop improvements of these machines. And I just give you here a short selection of this, and we have heard it in the previous presentation as well, power curve upgrades. It's just 3–4%, but just something. And this all improves your business case over the term. Minor moves, major impact is the keyword here. But having all these areas of excellence, we just decided as organization to put this in programs. So as you can see here, we have these key products for the onshore business. This is the 100B, 200A, and 300W, we call it. I mean, most of you may know it. The main difference is, I just guide you through it, the scheduled service, the 100B is purely scheduled service. It is applicable for, call it very old machines in a sense. Then we have the 200A, which covers remote diagnostic services plus the scheduled service and an availability warranty. Means our risk exposure goes up, the complexity of the product goes up, and so we have this product which is an availability-driven product. And the last one is the 300W, which is adding a component warranty. In simple words, it means whenever something fails, we repair it over the time of the, let's say, service agreement. The other ones, the 400s are offshore products, so I will not emphasize on this because I'm not quite sure how the offshore business is in Turkey. It's not my field of business at the moment. Looking into it, what the customers are buying at the moment is, as you can see here, we have the geared turbine, the direct drive machines, and you have the portfolio from the 1 megawatt machine up to the 6 megawatt machine, whereas not listed here are the old machines which we are maintaining, which are 150 kilowatt machines, which are still in the portfolio of Siemens, but I mean they are of no importance in the sense of the future development. So if I focus on the 2 megawatt and 3 megawatt machines, what you can see in green here, so you see what type of contracts are the ones which are sold globally. So you can say it's a mix of 200As and 300Ws. And if you would ask me what is the right approach here in Turkey, what is the share here, I have to admit I couldn't tell you because we have a couple of meetings in the past, and whenever you talk to a customer, you get different requirements. The one wants this, the other this, more risk, less risk. So at the end it's tailor-made. The good thing here is with our programs that we are able to adjust them here and then. But to keep it simple, we have these products developed and sell them accordingly. Just a short outlook into the trends in operation maintenance, and this is not a sophisticated study of Siemens or somebody else. It's just an observation which applies for some markets. What will happen is that we believe if it's a mature or older technology, that it gets more and more in the direction that our customers of a certain size will do certain parts of the service themselves. So means the standard maintenance activities to impart bow tie tensioning. I call it low profile work. So things which can be done because it gets repeated regularly. But the total future will then go into the numbers, figures, data, so data management. I mean, as you can see here, 400 sensors are in the machine. They're creating 1 gigabyte data every month, 3,200 parameters, 40,000 calculations. I mean, this is huge numbers of data, and the big question is, what are we going to do with this data? How can we use them better to bring the machines forward? And here, I think, is the future for many of the turbine suppliers and, let's say, sophisticated service providers, that these data shall be used in the right way by data analysis, remote monitoring, statistical data handling, and creating products out of it. So this is where I will see, or where I see the future to a certain extent. Nevertheless, we will have all the service packages because, as you know, banks like safety, and so this kind of products will be requested further. But there's a little tendency of what it might be. I'm not touching too much the monitoring and the remote diagnostics, and I think everybody who's dealing with wind turbines knows this. There's a turbine, there's a server, there's an internet, it goes to a service center where all this data get collected, and in case it is needed, the technician goes to the site and is fixing what happened, or you can repair it by remote. The new thing what we have is the so-called Wind Dialogue, which is a portal where our customers directly can access their machines with all relevant data which are needed, like reports, like operational data, and so forth. But the key message I want to bring here is that all of our products which we have in the service as a standard service, this I told you 208, 300W, have this remote diagnostic services included. And this is, I believe, value to you. And at the end, this will turn into better products which we can provide as a service provider. Just little statistics. So out of this remote monitoring and the success, so that we can respond in 99%, more than 99%, within the first hour. So approximately 80% of these alarms will be handled remotely. That means no technician is required. And in terms of the vibration diagnostics, we are doing more than 20,000 vibration analyses will be done on a yearly basis, actively and proactively. And what we have seen is that the detection hit rate is quite high. As you see, 97%. I mean, it must not be many cases, only a few are sufficient, but we find them with this systematic. And the reliability or technical availability of the system is more than 99%, which is quite good. So this is what the machines are doing. They're talking to us on a daily basis, and we just have to learn what the machines are telling us and take the right, let's say, conclusions and turn this into products. So coming back to the beginning, and I changed the slide a bit because at the end I'm sales, I'm marketing, I have to do this. So I changed it to these questions. What is Siemens able to deliver? I believe we are able to deliver most of it, if not saying all. I believe that we fit to the needs of the market because we listen to the customers, we listen to the machines, and we will be there and develop the right things. Is Siemens reliable and deliver when needed? I think yes, at least we have not so much complaints about what we are doing, so we have quite good positive feedback in the market, especially here. Will we sustain over the term? I mean, having 150 years in the back, I'm not really nervous on that. Can I, as customer, afford it? I didn't answer this. This is a question where you have to ask yourself. I strongly believe that we are able to do so. The only thing what I can say, whenever we have a commitment to one of our customers, we never let you down. We will always be there with you until the very end of your machine. Thank you very much.
Michael'a teşekkür ediyoruz konuşmalarından.
Thank you, Michael. So, just to give you a recap of what he has told us, he told us that Siemens started the first installation in Turkey back in 1933 and entered the Turkish market. And Mr. Neumann asked 5 questions about creating value to the customers, and all through the presentation, he sought to find answers to these questions. He explained that they're providing an entire chain of value, and after the commissioning of the turbine for 15 to 20 years, they're working with the turbine manufacturers, that they're good business partners, and this 15 to 20 years should not be underestimated because it's a really remarkable factor. And he said that they are providing 15% of the entire supplies provided in Turkey by Siemens, and he also explained us about the installed capacity of the company in Turkey. He also continued discussing about the service provider characteristics of Siemens, how different the company might be from small companies. In terms of scheduled maintenance services, these are relatively easier to be provided. But whenever there is a problem with the turbine, responsiveness might be an issue. In terms of spare parts, spare part guarantee, and being able to do that throughout the life cycle of the turbine is an important value which they can do. Also, he covered about the remote monitoring systems, about the level of development, and currently there is 1 gigabyte data received from 400 sensors, which is huge data that needs to be analyzed, and as a result of these analysis they are taking action. And an interesting thing is 99.54% of the total received alarms can be responded in an hour. Thank you very much, Mr. Neumann, for this interesting presentation. Now, Dr. Slim Sowa will be taking the floor, but as I have done with all the speakers, I would like to introduce him. Dr. Sowa is an expert for condition monitoring. Has been working in the field for 12 years. This is his field of expertise. Damage-free test methods are his thesis for doctorate, and also he has a PhD work. TWI is the company that he's been working for since 2007, and also the guided wave technology is actually his field of working in the development projects. In the last 5 years, particularly in the energy sector and with relevance to the aviation and renewables, he was involved in more than 10 EU projects where he did projects and created value. The floor is yours now, sir.
Thank you very much. First of all, I would like to thank you, Mr. Chairman, for the opportunity that you gave us as TWI, but also as the consortium of the CMS Wind project, to actually share with you this experience that we started 3 years ago. So CMS Wind is actually a project that was funded by the European Commission. We are grateful for the EC because they keep sustaining this R&D activity in different industrial sectors. Renewable energy is one of them, and actually it helped us as a consortium, so including research and technology developers like Fraunhofer Institute, like Brunel Innovation Center, Inora in Greece, and other SMEs company, as you can see, including TWI as well, the Welding Institute in the UK. We actually worked for the benefit of the associations like TUREB, like the German Non-Destructive Testing Association, the Spanish Renewable Energy Association, Wind Energy Association, sorry, and the Spanish Non-Destructive Testing Association as well. So CMS Wind is a project which is targeting the profit of the association, and actually behind the association is targeting the profit of the members of the associations, including SMEs, including big companies as well. So in this context, I mean, we come from a different perspective, which is complementary to everything that you heard already in this afternoon, and I guess during the whole event. It's the importance of research and development. As you know, I mean, in this presentation, we are not giving anything new. I mean, in this sector, everybody is aware of the challenges, and everybody is able to provide a kind of profitable business, either in terms of service provision or in terms of providing equipment, installation, and running this equipment. However, there will be always questions to answer, and these questions are all the time based on the cost, based on the business model. So there will be always possibility to improve the business. So, and that's where R&D is important, because it gives a new idea which everybody can use and improve the business from there. So, so actually in my presentation, I'm gonna just introduce my company and then talk about the importance of condition-based maintenance, especially from a cost model perspective. Then I will just present what is the outcome of this project, CMS Wind, that was running for the last 3 years. By the way, it's finishing in 2 months from now. And we are happy with the progress that we made, and with the opportunity that we had to know all these nice people from everywhere in Europe and Turkey, and especially from Turkey, that we actually built a good relationship and actually future plans for collaboration with our partners from TUREB. So I will talk about demonstration as well and validation. So our company is basically aiming to, is basically the Welding Institute. It's based in Cambridge in the UK, and the objective is basically to reduce risk in different industrial sectors. It's all about cost as well, so to avoid costly remedial actions, reduce environmental impact, and so on. So our turnover is around 55 million. Now it's a bit more than that. We have almost 800 staff around the world. So we have members. So basically we deliver our knowledge and service to our members. But we have also partners, not necessarily members of the institute. And actually we help them. And at the end we don't make profit. So actually we are a non-profit distributing company. We are based in 5 areas in the UK, the main headquarters in Cambridge. In the world, we are based in several areas, in America, in Middle East, in Europe as well, and we have an office in Istanbul. We provide service to our members, but we also develop projects with them. And especially in the last like 10 years, we have developed more than 85 European collaborative projects. That's where we develop the research, and that's where 30% of our activity is actually sitting. Our expertise is about joining. That's what we started doing since 45, but actually after this, we looked a lot at structure performance, material engineering, corrosion mapping, and management, the modeling and simulation, inspection, quality and safety, and surface engineering. We provide service in research and development by doing consultancy, manufacturing, fabrication, repair, also in situ assessment, failure investigation, technology transfer and training and certification, and also we sell softwares. So I'm coming from the integrity management group, and actually in this group there are 7 sections. Asset integrity management is actually an important aspect, and they're all linked together. That's where we can work with people from condition monitoring, fatigue, fracture, numerical modeling as a support, non-destructive testing, and then we do also validation of the new technologies. We do business development in several areas, and research and development is actually coming from this action, and that's how we know new partners. The integrity management group activities is actually listed here, but the main ones are NDT, non-destructive testing, and that's where we started looking at condition monitoring using techniques which are non-intrusive. Then we look at failure investigation, we look at mechanical testing, risk-based inspection, which applies to all the sectors. These are the systems that we have, from ultrasonics to magnetic, acoustic emission, decurrent. All these techniques are actually applicable in several industrial areas. So condition and structural health monitoring is the section where I actually am managing. And specifically for this project, we looked at how we can apply condition and structural monitoring in the wind sector. And the reason is basically everything that you heard already in this event about cost reduction, about hazard, about risk. So actually that's where we try to help our partners. Specifically, we look at machinery vibration. We look at now more advanced problem where we have to use a combination of techniques. Acoustic emission is one of them, guided waves, vibration, but also all the correlation with parametric inputs. So this applies in different industrial sectors, as you can see. And that's where we try to design a specific algorithm and software for each specific problem. So we develop these techniques from the modeling, basically low technology readiness level, until actually the high TRL level where actually we can even provide a product to the market. This is an example where we have designed a system, and that system is actually taking information from structure like foundation for and support structures for wind turbines, and based on this information actually we can do data fusing and then define a trend analysis, and from there this information can be used by the end user. So that's where we try to design new strategies based on the need. So coming to wind turbines, obviously condition monitoring is well known and it's already integrated. However, what could help is to provide a tool to the operator to be able to manage his information and manage the data the way he wants. So there is a need to have a flexible software, an open platform, which allows the operator to collect the data and then to monitor and to correlate the data based on his experience. Where we are coming from is from the fact that every wind turbine is actually different. It's in a generic way, when we look at it, it's actually all following a trend, but the trend is changing. And the actions, even maintenance actions, are actually making this difference. And that's why we think that there is an opportunity for the operator to have this platform and become able to make his conclusions. So this is an example of what we could do with a flexible system and a flexible software. It is possible, for example, to monitor fatigue-induced cracking on a 45-meter blade. So, for example, in this case, we have introduced a crack, and then we looked at how this crack can progress by capturing the acoustic emissions. So actually, acoustic emissions are waves, which can propagate inside the structure after the generation of a crack. So this type of waves, they can show, as you can see, with the distribution of waveforms. And these waveforms can be detected and then classified, and then we can warn about the propagation and the progress of a cracking. It's very difficult to have a strategy which can deliver this kind of information without actually tackling the problem to do with noise. And noise is not necessarily about electronics. It's actually coherent noise. It's basically about friction. It's about vibration, and all this is not actually related to cracking. So actually, in this case, for example, we could identify that the relevant crack propagation acoustic emission is actually almost less than 5% of the captured data. If you take an acoustic emission system from the market and then you just try to deploy it and then just look at what it can give, it's basically going to be bombarded with information. It's very difficult then to keep the system silent to false warnings. And that's actually the work that we can advance in order to understand exactly what is the information that is relevant to crack propagation. Also, we can locate the events where the acoustic emission relevant to cracking is actually happening. And from there, over 9,000 data set, then we could just identify 100 which are relevant to cracking. So all this work is representing some filters which could be deployed, and then from there you can give more strength to the software and to the strategy in order to give information, relevant information, not just false warnings. So within the CMS Win project, we have designed specific hardware, but actually the objective was to find the final criteria which can lead to a red, amber, and green light. And from there, the operator can, in between, put his own knowledge, means the own knowledge of the wind turbine, the knowledge of the history of the wind turbine, the knowledge of the maintenance actions that was actually applied. It could be applied to rotating machinery. It could be applied to cracking in moving parts, like the case in the blade that was shown. Could be also deployed to shaft bearings misalignment, although all this is basically very, very well known. The sensors that we are using are actually a combination of acoustic emission, vibration, motor current signature analysis. Wireless sensors has been introduced. Also, it is important to look at energy harvesting. So acoustic emission, in few words, is actually very similar to vibration. It's just that it looks at higher bandwidth of frequency, and basically it can look at the long time deterioration through either the friction or actually the loss of material. And that's why it's a technique that is more relevant to monitoring than to inspection. Inspection is basically always based on the knowledge of the initial state of the machinery. However, acoustic emission can monitor and can give information relevant to loss of material. Vibration analysis is well known, so I will just skip this one. Motor current signature analysis as well looks at the outcome of the power, and then it can determine defect problems at early stage as well. So all these, maybe apart from acoustic emission, all these are not new techniques. So we have integrated all this, and we have given a flexible software which could correlate all these measurements together. And that's I would say not the innovation, but at least the flexibility that is given to the operator in order to build his own long-term monitoring conclusions. So that's the system that we have designed, and then we had installed it in, for example, in this case, in a nacelle that we use for the trials. So here you can see that what's happening is an automated generation of signature. So basically, because we have the control of this nacelle, then we can generate the signature of the nacelle, and from there we start the monitoring. And when we start the monitoring, we compare it to a specific signature which is actually specific to the turbine. So it can give this information which relating the wind speed and the power. It's well-known information that the SCADA can give as well. But also it can relate the time signal, either accelerometers or acoustic emission as well. So based on what we call the binning process is actually we look at every set of data with regard to the specific bin in terms of power or in terms of wind speed. And from there, we can determine a specific range of safe operation for a specific power range. So basically, this is what we call the signature. So this is now automated, and it can be applied to any specific measurement that the operator can do. So then yes, 1 minute, yeah, okay. So all this is implemented in the software, and then the software gives the baseline and the signature, and from there it gives the operator time to react to any change and permanent change that comes outside the standard deviation that he can define. So we did the validation based on existing systems, and from there we could define the right, for example, vibration spectrum, and we had compared it to the commercial systems. And basically now we are in a stage where we are negotiating to install the system in different wind turbine area, and our friends and partners at Tureb are helping us on this as well. The next step is also about dissemination, and we have many events where we are covering. Today is one of them. We have training material, and that's one of the business points that we would like to take forward. So actually I finished within 1 minute. So yeah, that's what the project is about. There is a website which has plenty of case studies which shows the performance and the sensitivity of each technique. And I'm happy today to be able to show you this experience, and thankful to our partner at Tureb, especially Mr. Sherman, who actually invested a lot in this opportunity. Thank you very much, and you're welcome for questions.
Dr. Sova'ya çok teşekkür ediyoruz. Sunumları.
Thank you very much, Dr. Sowa. I will just summarize quickly. There is plenty of information on the website of TWI, and Dr. Sowa just explained the EU project. One thing particular, though, you might find detailed information on the website is that the turbine has a signature, turbine signature, which is providing you a signature after there is monitoring of the data. And after a while, after tracking all this information, all that data, if there is something that is going wrong, that would warn the producer. Actually, this is a project where Tureb is also a counterpart for. You may find detailed information from the website. Thank you again, Dr. Sowa. The last speaker of the session will be Kenan Haifavi. Let me just introduce him to you. Mr. Haifavi was born in Ankara in 1969, and in 1991 he graduated from he started the Middle East Technical University, graduated from Civil Engineering Department in 1994, also had MBA again in Middle East Technical University, Ankara. In 1996, he started working for Dosar Engineering for feasibility works of hydraulic projects. Then in 1998, he worked at Yamula Dam and Hydroelectricity Power Plant, worked as a technical manager for 6 years. And this was followed by Soyak Energy in 2006, in charge of design works. And since 2008, he's been working for Gamma Energy. and currently he is the Deputy General Manager in charge of renewables. Also, he's a member of the Executive Board of TÜREP.
Teşekkürler Sayın Başkan.
Thank you very much, Mr. Chair. Ladies and gentlemen, participants, my colleagues, thank you for coming. I know this is the last day, the last panel, and the last speaker. So briefly, I will try to provide you a recap of what we've been discussing around in these last few days. Now, the main theme of the session is operation and maintenance, but of course, I would like to touch upon to wind energy before starting. As we all know, electricity energy has been increasing in countries like Turkey, as developing countries. So as to meet this growing demand, energy investments should be made correctly and in a planned fashion. Now, for planning, we know that energy diversity and planning of this diversity is quite vital. Now, in Turkey as well, in our country, since 2005, we have started receiving many investments in renewable energy that was boosted after the renewable energy law, mainly with hydraulic, followed by solar, and recently, as of the last year, in wind, we have been investing in different modes of renewables. I think there is a fast progress here. As a matter of fact, 3,750 megawatts have been already achieved for wind installed capacity. I think this is a level that should not be underestimated, as Mr. Chairman has referred to in his presentation. Since last year, 870 megawatts of additional capacity has been created. Now, when you take a look at the increase since last year, it's 27. Quite good, but looking around the globe, we would see, and when presenting this presentation, I checked the literature and I've seen that the previous year in Germany, in 2013, 3,300 megawatts of extra capacity was created. So as of last year, let me just show you the slide that I prepared about last year.
5.000 megawatt ekliyor.
They have added 5,000 megawatts, which is gigantic. I mean, considering the fact that the installed capacity is currently 3,750, this is gigantic. So about this, of course, both legal and bureaucratic environment, economic environment, policy making, or the decision making are the important components. Why not? I mean, if these components are achieved, it can be the case, but Turkey is just in the crawling stage, so 20,000 megawatts by 2023 is our target. So I think every year we should be adding an extra of 2,000 megawatts at least to achieve that target.
Bu tabii birçok farklı konu var ama
there are many different dimensions to, of course, this debate, but operation and maintenance with the perspective of investors will be the theme of the presentation. O&M are important items. Particularly after the commissioning of the turbines, when even starting a investment, actually we put into consideration the inputs to the feasibility, because if the costs are increasing, the feasibilities might be looking negative. Actually, the economical scale of the wind turbines are somehow affected by this, because there are 3,750 megawatts still operational in Turkey, and between 1,500 to 2,000 we have turbines installed in Turkey. Compared with the situation 6-7 years ago, it's tenfold. I mean, it was 300 megawatts, I guess it was in 2008. Now it's 3,750 megawatts with more than 1,500 turbines. So O&M costs, quite naturally, will be increasing. There are suppliers providing these services, and of course, the costs are, with the development of technology, somehow reduced. Of course, what are the components of operational costs? Here today there are many ways we can tackle this. Both, there are some maintenance agreements you can have with the equipment providers, and 1-2 years, of course, automatically covered by this contracts. Then there will be an extra 5-year extension of the contracts for turbine maintenance, which will be coming up as an extra cost. Also for the ancillary costs for the equipment and infrastructure costs, like some breakdowns and the relevant costs that will come up. Staffing and management expenses, leasing of the fields would be an important item. Of course, there might be a variability for this cost. Taxes, balancing mechanism expenses, insurance, transmission and distribution system utilization shares will be the general components of the O&M costs. Operation and maintenance costs, let's take a look at the situation in different parts of the world. Let me give you some examples. You can see Germany, 20 euro per megawatt hour. And in Turkey, it's there are two figures for Turkey. The first one is with a forest permit of 85% discount. It's 2 euro per megawatt hour. It's an important cost, I have to say, for the forest permits. It's some cost that should not be underestimated, because it's depending on the site of operation might be somehow higher. In the UK, more or less the same field, around 18 euros. In the United States, 15 euros of this cost will be seen. Again, within itself, there is a distribution. So for Turkey, you can see the fact that there is something that is important. Breakdown and maintenance looks like zero, and the reason is most of it is in the scope of scheduled maintenance. For services and maintenance contracts will be covered automatically according to the contracts. Of course, operation and maintenance contracts do have a scope that I have to speak briefly about. Here, one of the crucial items is the maintenance and repair contracts, where the scheduled maintenances do include spare parts, which is important. As the number of the turbines are increasing, the suppliers, together with the repair and maintenance companies, do provide more number of spare parts, where the costs, I believe, will be reducing. Monitoring and reporting, I have to say, is, as mentioned, quite important. Availability also might be affected by this, because in the right time there should be the availability of intervening. I think monitoring and reporting quite important. Repair and maintenance consumables. In some conditions there might be the need for some special repair items, which might sometimes be problematic to be transported or brought to the zone temporarily if the full service agreement is not given to the parties. So this might be a problem, because it might come up as a different item.
And especially some damages that may occur in the services actually should not be overlooked in these types of contracts. And also we have the fiscal liability and the insurance as well. And at the same time, there are some risks associated with some failures and breakdowns. For example, whether during these downtimes, whether they are covered under availability guarantee or not, there could be some mistakes with regards to generation itself. There could be some challenges with regards to troubleshooting. Sometimes we have some difficulties in having access to the site itself. I think this is also making reference to the very initial phase, because when you're making a planning having for any power plant. The access roads are not used only for erecting the turbines there. What is important is at the same time it must be sustainable, because from time to time this is actually something, as much as I heard from some of the PPs in Turkey, because of some of the problems at the access roads, sometimes timely response may not be possible, and sometimes there could be serial errors, and this also could be normal, but we at the same time should consider the reasons for this, and we have to report them properly. And again, there is actually the need for having the insurance and availability of components. The maintenance periods, as you all know, the manufacturers are actually already giving these. And looking at in general the breakdowns, and they're important because they even affect the spare part supply. Mainly there is the pitch system, especially with regards to blades. This could be a problem, but mainly actually the one of the most important item that actually may affect the cost is the gearbox breakdown and failure. They actually can very much affect it. Then it is followed by the generator. The blades, as I told you, but just the pitch system errors, and because of the lightning, sometimes there could be some physical damage and failure on the blades itself, on the surface of the blades, and they actually can be recovered very soon. But the gearbox itself is actually a cost on its own, and there's actually a 5-year period for the time being, according to the PPs that we observe in general. Coming to the conclusions, I would say the operating and maintenance. First of all, the operation itself is important. Starting with the provisional acceptance of the power plant. It starts, and this period must be very well managed. And today we just hear some of the power plants in particular. Besides the O&M expenses, on the top of this, just because of some lawsuits, even there could be the cancellation of the power plants, and even the operation in these power plants can actually be stopped. And of course, I don't know to what extent we can overcome these challenges, but at the same time, I think the lawmakers and at the same time the EMRI, I guess, should just regulate it somehow. If there is, for example, any power plant that is commissioned, we actually have to avoid some misassessment as well. As much as I know they are making some works and they also have certain thought on this. This also would be nice, in my opinion. Why? Because that could be actually a misjudgment by any lawsuit. Therefore, any power plant that is in operation may be subject to the suspension in their operations, and I think it is actually important to overcome these, especially for the power plants to be operational soon. It's extremely important, and there is actually an important wind potential. And especially we have theoretically 48,000 megawatts, because we are having the target of 20,000 megawatts until 2023. Is it accessible? Yes, of course it is accessible, but of course it is not impossible, but hard to achieve, because we need a 2,000 megawatt of additional installed capacity required per year. We have reached to 800 megawatt by now. I don't know, we even may reach up to 1,000 megawatts in the upcoming year, but of course, having such a rich potential, both for the investors and for the banks, it is important. And at the same time, for the turbine suppliers and also for the service providers, for the O&M part, I don't know, maybe the turbine suppliers are at the same time providing operational and maintenance as well. I don't know, it can actually provide for many opportunities, I can say. Therefore, Turkey can attract all these investors. I'm sure that thanks to this, there will be an acceleration in this process. And thank you very much for your attention.
Kenan Bey'e biz de çok teşekkür ediyoruz. Ben hızlıca özetleyeyim Kenan Bey'in bahsettiği önemli noktaları. Almanya'nın yılda 5200.
Okay, let me give you a summary. The speaker said that last year there was, even in 2013, it was 500 megawatts of turbine installed, whereas Turkey only could do with 800 megawatts. And he emphasized that this needs to be increased because 2023 target is 20 gigawatts, and we still have a long way to go to achieve this. Actually, there are some important data Kenan shared with us. For instance, per megawatt hour operating cost is 20 euro in Germany, which is 18 euros in Turkey, and only with the cost attached to the forest permits, there will be an extra 2 euro. And as I said, he has very important assessments when building a road. Of course, we should be thinking about the operational phase, as he emphasized. At the same time, a proper management of the roads would have a direct implication over the intervention times. Also, he emphasized that the breakdowns are because of the gearbox, generator, and the blade, mostly. Particularly, the breakdown of the gearboxes would come up in 5 years, as he explained. And one thing he explained was quite remarkable for Turkey, especially the plants that are operational in Turkey might sometimes be stopped, halted in terms of the operations, in terms of legal procedures. So there is some review work going on about this not happening. Okay, ladies and gentlemen, we've heard 4 valuable speakers today in this final panel, presenting you in their own fields of expertise. If you like, you can ask your questions right away now.
Arkadan, evet.
Is this working? Yes, thank you. Thank you all, gentlemen, for your presentations. It was very interesting. I have a question to the delegate from Vestas. You spoke about 3 things that you can do with your turbine from data analysis. And one was an uprating of the power curve, the second an extended cutout wind speed, and the third an aerodynamic upgrade. Now the only aerodynamic upgrade I can think of is fine-tuning the pitch angle. Do you mean this or do you mean something else?
Tercümeyi yaptılar. İsterseniz siz Türkçe cevap verin. Ya da tam tersi de olabilir. Her türlü imkanımız var.
Türkçe olarak ben cevap vereyim.
Thank you very much for your question. I didn't have the chance of getting into the details of the aerodynamic upgrade, but the main feature of aerodynamic upgrading is the turbulence taking place in the blade is minimized. In other words, the flow onto the blade, as much as possible, will be made smooth. Will be minimized so that the effect due to aerodynamic turbulence would be minimized. In other words, there will be a contribution of this factor to generation. Has this been an answer to your question? I don't know if I could. Otherwise, please tell me so that I can get into more details.
Yes, it's getting more clear. Would that maybe be a decreasing of the roughness on the blade? Else maybe we can get into the details later.
Anlayamadım ben.
Could you please repeat once again your question, gentlemen?
So it's making echo. Sorry, I couldn't get you well.
Okay. I was asking, would that be a decrease of the roughness of the blades, perhaps? The decreasing of the turbulence on the blade?
Eğer doğru anladıysam kanat
If I could get you well, this aims at reducing the turbulence on the blades. Yes. How can we do this? There are some additional vortex generators that we are using onto the blades, where the flow on the blade would be more linear, more smooth. So there is a flap mechanism close to the root where the power can have a better retention capacity on the blade. When doing this, of course, the upgrade, whether it brings an additional load to the entire system or not, will be checked by the design team. If this is within the design limits of the turbine, will be applied.
Thank you for the explanation.
I guess all the presentations were crystal clear and we don't have any other question. Of course, this is the very last moment of the Congress and it's been quite late. We've been furnished with a lot of the information. Once again asking, do we have any question? Otherwise, I'll have to close the session. Okay, then this brings us to the end of the session. I would like to thank all the panelists, participants, distinguished ladies and gentlemen for their attendance. And I will be presenting you my certificate plus a token of appreciation for attending the session. Then we'll have a family photo taken. Thank you very much for your attention. Good evening.